Okay, for our first topic, we're going to discuss number types. Now, when you dive into mathematics, you have to understand what you're dealing with, the tools, and that's part of math. You have to understand the language. So, for example, if you go to a different culture, let's say you go down to, let's say you go to Japan, and you don't know how to speak their language. And it's always easy to kind of see, if you can communicate on their same language, you can understand what they're doing. And that's hard. But so in math, it's all about the language. And if you can understand the language, but you also have to know the definitions. And that's what we're going to really get into as well, learning those definitions. Because in order to learn mathematics, you need to know definitions. So for the first topic, we're going to go over number types. Now, number types are funny because there's a lot of them. And they're not just one. So, for example, whatever I write on the board, please write. So let's say that I come up with 5. And you'd be like, okay, what does that mean? Well, 5 what? Maybe 5 X's. Maybe 5 X's. Well, that means, okay, 5, that means 5 X's. Okay, 5 fingers. So maybe, fingers. 5 fingers. Actually, this might be good. So that's 5. 5 toes. 5 crowns. Okay, so it means it's a number of something that represents some quantity. So some quantity. It represents some quantity. So if we go back to the Babylonians, Mesopotamia area, which is about 3000 BC, they run into this. Maybe you have, what about, looks like bowls of something. Maybe you have some pebbles. You have some pebbles. Maybe you have 5 rocks. Well, that means the same thing. So let's go into these number systems or number types a little bit and kind of build where we should go with our numbers a little bit. So if I erase this, don't worry about it. Just keep writing. It should be there. So let's go with our Babylonian friends. If you don't know who the Babylonians are, they're pretty much our first Greek mathematicians. So let's go to our Greek area. Our Greeks. And they like to be very curious. A lot of our math came from the Greeks. Numbers we really don't know where numbers came from. They just popped up somewhere. They could have been developed. We don't know. I'm not an anthropologist, so I don't have that answer for you. So let's go through our numbers types. So first one, well, they like to use, you can use your fingers, pebbles, sticks. So we have 1, 2, 3, 4, 5. ... means it goes on. ... means it goes on. And I'm going to do this. You ever saw one of those before? They're like a bracey. Like a bracey. If you're not an expert at doing these braces, they're like this. Do it again. If you're not good at this, don't worry about it. I was terrible at them, but I got better. Practice. So those are bases. So these are what we call the counting numbers. So these are the counting numbers. These are the counting numbers. Well, we like to call them counting numbers, but they're actually also called natural numbers. So these are called counting numbers, but really they should be referred to as the natural numbers. Okay? Our next one, well, what about 0? There's no 0 in here. But zero's a number? Right, 0 is a number. But a lot of civilizations back then didn't like 0 because how can you have 0 something? $0. It was a very bad idea with a lot of cultures back then. It took a lot of time. There's many books about how 0 became, which I do. I have a lot of them, and I can share that information with you someday. But 0, where does 0 come in? So that's another type, another number type. So this is 1. The second one is what we call whole numbers. Okay, so we have natural numbers, whole numbers. And whole numbers, they have 0. They start with 0. So they go Bracy, 0, 1, 2, 3, 4, 5, ... on, in Bracy. So that's what that means, whole numbers. Okay, well, another thing came along, and now we have what about negatives? Oh, you can have negative dollars in a bank account. What I mean by that, so the third type is what we call integers. Integers. INTERGERS. Integers. Let me do that again. Integers. Integers are where those negatives come in. So do a bracket. This time we're going to go like this. Dot, dot, dot. -3. -2. -1. 0. 1, 2, 3. Dot, dot, dot. Close. Those are what we call the integers. Those have negative values in them as well. Now, I want to come back to that negative part. What I mean by negative numbers, you can get what we call in a bank is called an overdraft. An overdraft, you don't need to write this down, but an overdraft is something that if you don't have enough money in your bank account, your bank says, well, you don't have enough money to cover this this amount that you're paying for. So what they do, they're going to charge you. And this is how banks make their money a lot of times. It's called an overdraft fee. So let's say your bank, they want you to cover that they want you to cover the amount you pay for it. So the bank says, well, we covered that, but we're going to have to add a fee on because you don't have enough money to cover it. So long story short about that, you can have negative numbers dealing with that. Negative numbers can also be like you're walking backwards and walking frontwards. Backwards like you're walking -3 feet back. But that's just the theory behind it. And a lot of you, some of you got the idea that this is -3, and some of you are going to say -3. I kind of consider them to be the same. So somebody can say -3, subtract 3, -3. So see how some of that language can kind of give your mind a spin? So those are integers. So you can kind of see how these are all playing into these. See how they're all kind of the same thing? They all have the same process. And we started with natural here, whole numbers here, and then integers. So the next thing that comes up is called the rational numbers. So rationals. Rationals are your fractions. So let's say that they are pretty much your fractions. So a lot of times fractions can be written as A over B. What does that mean, A over B? Well, let A and B be a number. So for example, 1/3. So A is 1, B is 3. 1/3 is a number. 4/3. 1/2. What about 2? Wait a second. You're like, Mr. Boss, 2 is not a fraction. What do you mean it's not a fraction? 2 over 1, right? Here's a $100 bill. I wished. Here's $100. How do you write $100 at a fraction? Over 1. Because isn't 100 over 1, isn't this 100? Okay. Well, those are good. So we're going to have all these different numbers here. Is this it? No. We got, I think, 2 more. So we got rational numbers. We got our fractions. Well, what about what we deal with every day? Well, this is what we call, I'm going to come over here if you don't mind. Hope you have this down. Number 5. Real numbers. These are pretty much everything. Decimals. So I'm going to do this. I'm going to go negatives, fractions, decimals, well, some of you can be like, what about that funny looking shit that we studied before, that long number that never ends? Pi. Pi is a decimal. Pi is a real number. It's a real number. 3.1415, yada. I think I mentioned this before. There's a thing called E, which is roughly about 2.7. This is what you're going to get into later on. This has to do with business and economics, also about exponential growth and decay. So you're going to get into that very soon. But pi you should know, which is roughly about 3.14. Usually, remember it's approximation. It's not actually equal to 3.14 because it approximates. Okay, cool. So you have real numbers, you have these rationals, these integers, and one more case. What about irrationals? So, for example, what's an irrational number? It's a number that does not end. So it does not end. it doesn't repeat. When I mean it doesn't repeat, it doesn't go like the same digits. So here's an example. Pi and E. So pi, E. What about this one? The square roots. The square roots. Some of you might recall what those are. If you don't, we will get into them again. It's going to be a little harder, but we get them. So square root of 2, square root of 3, square root of 7, yada, yada, yada. So those are called irrational numbers. It means there's numbers that don't repeat and really never end. So let's put this into a final tally or a final overview. A lot of stuff here. But once you know these number systems, these 6 number systems, oh yeah. Because this is the foundation of what we're doing. So, here we go. What you're going to do, by the way, if you get onto the end of your binder paper, just go on the back. Just keep going. Just keep going. Keep taking those notes, even though I erase stuff. So just keep going. So let's do this. We're going to make like little bowls, like bowls. When I mean bowls, so we have, actually, hold on. Okay. Something like that, little cylinders, I guess you can say it. Little, yeah. So these are the natural numbers. These are naturals. Okay. Those go into the whole numbers. So naturals go into the whole. This goes into the integers. So you have naturals, go into the wholes, go into the integers. These go into the rationals. So naturals, whole, integers, rationals. Okay, those are the ones we use all the time. And over here, these are what we call the irrationals. So these are kind of like their own little cup. So you can't see that. This is like a big, this is like the big cup. This is the big cup, final cup. So we have our natural numbers, 1, 2, 3, 0, 1, 2, 3, 4. Integers, negatives, and 0 and 1, 2, 3. Rationals is all the ones with fractions and zeros and ones. Well, where do all these drain into? So drain, 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 drain. Drain also. What are they draining into? If you go back to your notes, there's one number system that they all pretty much have everything in them. That is what we call the real numbers. the real numbers. So everything that I've talked about throughout number systems all goes into a big old funnel of real numbers. They're all real numbers. Now you're going to be like, Mr. Boss, well, what about that pi? Pi is a real number, ladies and gentlemen. Pi is a number. What about the square root of 51? That's a real number, of course. We are going to get into something later on. I don't know if we're going to get it to this year, but sometime we're going to start using I. Now I give you a little hint for preview. I is actually equal to the square root of -1 or -1. But that's for later. But what I want you to focus on is these are the basis of our mathematics that we're getting into. Every math class, if you go on to more advanced math class, has to do with these fundamentals of numbers. So hopefully this helped you out. If not, you might have to watch this video again. Remember, it takes practice. You might have to watch this again and try these out. Do I really want you to know these? Of course. This is the foundations of what we're doing. So, hopefully this worked. Hope you got these written down, and I will see you in the next video.